Now is the time for our next panel, From Ideas to Reality in 6G Times, a challenging topic. Florian is the moderator of this panel. Florian, please. Florian is professor at EURECOM and a well-known figure in the OAI community. He's one of the biggest contributors to OAI code. So many of you know him. Welcome, Florian. On the panel, we have Ben. Ben is with NI, and he's a board member of the OpenAirInterface Software Alliance and a big supporter and backer of OAI for the longest time. Welcome, Ben. Okay, and then we have Chris, NVIDIA, a well-known figure to all of us in the OAI community, a board member at the OpenAirInterface Software Alliance, and also a great supporter and backer of OAI. So, Chris, welcome, please. Doug Nicely from Qualcomm. Again, board member at the OpenAirInterface Software Alliance. So, the panel, I'm expecting them to say good things about OpenAirInterface since, all of them are board members here, many of them in any case. Yeah, Doug is also a long-time backer and supporter in a big way of OpenAirInterface. Doug, welcome. Then we have Hanan. Back again, Hanan, please. And Hanan is also a board member at the OpenAirInterface Software Alliance. Welcome, Hanan. And lastly, Ganesh, who is manager, I suppose, at Radisys. I don't know your exact title, Ganesh, but you are also a longtime friend of OAI and very well-known figure in the ORAN Alliance, chair of the Working Group 8, and very, very effective and active leader over there. Welcome, Ganesh. Yes.
All right, thank you very much. On. Yeah, that helps. All right, thanks Irfan. Yeah, so it's my pleasure to chair this panel here on From Ideas to Reality in 6G Times, Open Reference Designs for AI-enabled next-generation cellular networks. So a lot of keywords packed into the title here. I'm very grateful for the keynote of Hanan earlier today because he set the scene for this panel. So he's not allowed to present any more slides here today in the panel, but I gave the other panelists the possibility to prepare some slides. So we might show some slides here. So this is compared to the previous panel, this is an industry-focused panel. So we're going to talk about practical questions, industry-relevant questions here. So before I give the floor to each one of you, the question is, we hear a lot about 6G, the different use cases and the applications, digital twins, intent-based zero-touch automation. We didn't hear yet about integrated sensing and communication, but that's also another keyword for 6G. Anyway, there are plenty of those. There's AI everywhere. What I want to know, what is actually relevant to industry? What do you in your opening statements? I'd like you to say what's relevant to your field, to your industry, and what you think is actually realistic. What will be part of 6G? How do we realize those things? And of course, what's the role of open source or open reference designs in those? So Ben, I'd like to start with you. I think you prepared some slides, right?
Yeah, I can go slides or no slides. I'm easy either way.
Yeah. So Yeah. Oh, here they are. Oh, all right.
Awesome. Well, I won't spend too long on these slides, but yeah, I think from our perspective, so NI, Emerson, we're coming at this from the test and measurement side of things, right? So we're really trying to understand what are the role of the SDR tools, of test equipment. How is that going to change in the 6G workflow, and what is needed really to be able to get to these systems that have very lofty goals. So let's see. Oh, there we go. So from our perspective, we're looking. I think AI undercuts a lot of this, and that's sort of the stage I'll set for our perspective. Is really trying to understand the role of AI in test, both in terms of how do we utilize AI in terms of generating tests, getting better insight from test frameworks, being able to prototype more easily with natural language, but then also looking at how generative AI is used inside the analysis side of this. We talked about data and how we aggregate data. It's very clear that in order to train AI networks, we're going to have to change our modalities of test for those networks. So from us, I think we're really, embedded trustworthy AI really is the name of the game of what we're looking at in terms of how we're able to support in this ecosystem. There's a lot of ways AI can be used in the RAN or in the network, but we have to be sure that it's going to be effective. It's going to be a net positive gain, whether that is from an energy efficiency standpoint or it's from an overall processing or optimization standpoint. And so, we looking at both the test side of this all the way to the semiconductor level, but also the research and prototyping frameworks. There's a lot of different. Everyone's looking at this AI problem of how to slice it, and what I think it merits is that we have to look at these open prototyping frameworks as a way to solve these problems. And so, this is just some of the work we were doing this year in terms of our reference architectures around OpenAirInterface with our software-defined radios, and then with some work that Kaushik and his team was working on us with around smart scenario testing. So really trying to identify what are the right test vectors when you build up a test system like this that are going to lead to the best results, and where are the failure cases in that, and where are the blind spots, right? There's a lot that has to be considered when we build these frameworks. And so as we iterate on how we look at how to prototype out this technology, it's very clear that we need more data in every single possible output. And so there was the question earlier about, hey, how do we get access to the data sets? Well, some of the things that we're working on to extend this is give you more data. So we submitted an extension to the T-Tracer API inside of OAI to be able to pull these KPIs more easily out of the stack. And then we're adding on to that and building out how we extend that framework so that we can really give you the insights. So, I think if we look at AI being applied in the network, we're going to need to shift from, 4G, for us, it was very much physical layer prototyping, and 5G was end-to-end prototyping. Now it looks probably more like digital twins or this type of HIL, system in the loop, hardware in the loop type workflow. And so this is just an example of how we're considering that with energy efficiency and benchmarking energy efficiency to get you these holistic understandings of how the network actually is going to be optimized. So this is kind of our perspective of looking at this from a test vendor standpoint.
Okay. Thanks, Ben. That's great. I really appreciate your contributions to OpenAirInterface and these frameworks that you provide. I think that's very relevant. I particularly like that figure with the test cases and that shows where AI is better than classical algorithms. I think that's exactly what we need to figure out. What kind of AI is actually good to implement in 6G. All right, I'd like to pass the mic over to Chris.
Great, thanks, Florian. Actually, do you mind if I stand upstairs so I can see the
No, you can come here if you want.
Yeah.
It's no problem.
Pretty easier. Thanks. Yeah, a few slides here. So in a nutshell, I think one of the important things that is critical for NVIDIA's view of machine learning, AI, ML, and wireless is really going from simulation to reality, right? Distilling all the interesting results that have been published in simulation, and do they really work over the air, right? You see here a chart where we get a kind of a healthy growth in the number of publications on AI/ML in the radio access network, but most of them are simulations. So one of our interests is really having research, encouraging and enabling researchers to be able to take some of these concepts and prove them out in reality. So there's and then the other part of it is frequently difficult to compare results. Maybe that's a slightly different topic, but so many papers on, for example, ML and channel estimation, kind of hard to be able to objectively compare what is really going on there. So moving from ideas to reality is one, extending simulation methodologies, and I'll one slide on that in a minute. Two, validation of ideas and benchmarking of concepts on real-world test beds, right? Availability of data and enabling research test beds to provide easy access to data in layer 1 and layer 2, and enabling end-to-end AI/ML real-time closed-loop systems where you can really explore some more advanced concepts where you've got training and inference happening at both ends of the link. And part of our initiatives in this area have been heavily based on our relationship with OAI. And so I think we've been fairly successful in making use of nearly everything in OAI for enabling some of the research test beds that we provide. And the open source part of that was critical so that people could change layer 1 and layer 2. In fact, the NVIDIA demo that's being shown here is heavily based on OAI. So in terms of extending simulation capabilities, digital twins, right? It's talked about a lot. Up here on a slide, we've got on the left one of the examples that was actually simulated on the Sienna Research Kit over there. There's kind of two parts in this video. Creating radio maps on the Spark GPU there, but on the left-hand video there, it's kind of creating a radio map of the entire United States in 5 minutes on something bigger, right, a bigger data center-based systems. And on the right, something actually we did with Kaushik, which was the use of digital twins and differential ray tracing for optimizing the positions of airborne base stations. Anyway, you can see there's some of the technology that was used to implement those simulations out front. The second part is around data collection, is kind of a key part of this theme. But if you kind of stare at this a little bit, what you'll see is an over-there real-time test bed that is based heavily on OAI, OAI-CN, OAI-L2, and NVIDIA Layer 1. We make use of the OAI soft UI as well, right, to enable this concept of closed-loop AI/ML at both ends of the link. And then another part here is around data collection, right? So being able to collect data from various parts of the physical layer, signal processing nodes in the PSCH pipeline, PDSCH pipeline, and be able to hive them off, in our case, to a ClickHouse database. And I guess like, excuse me, NI Emerson, we too actually will release in December some extensions to OAI T-Tracer for being able to extract out data from SoftUI and also the Gnode B in this system. And these systems are 5G compliant over-the-air systems. One example, which is at ETH in Zurich, this is a data collection experiment. So you've got, it's hard to see, but there's 4 4TR commercial grade radios here. There's an infrared tracking system on this drone here. So we can collect data sets here that are showing the 3-dimensional position of the drone. And in this particular case, we're saving off channel state information to a database. So you can have a labeled database, which is CSI labeled by positional coordinates. And this is all enabled with this real-time over-the-air test bed. And then finally, for the end-to-end part, being able to close the loop around data consumption and pulling out or creating features from data in the receive symbol, doing online training, and being able to update or modify or fine-tune parameters in network is also a new capability in video release in the form of distributed applications in December, where you'll be able to pull data in real time, but also process data in real time. So you can consume data, online train or online inference, and be able to feed back updated parameters to the physical layer or layer 2 scheduler. I'll leave it there.
Okay. Thank you, Chris. I can already see a theme here, commonalities between the two, on the data collection frameworks and the need for the need for that and the need to collect actually data sets to train all this and validate all these algorithms. So thank you for that. Let me pass over to Doug and his view on open reference designs and you know, how to bring theory to practice in 6G.
Yeah, I don't know if you have the slides, but it's probably not too important in the interest of time because I agree with so much of what's been said.
No, they're not there. So,
it's all right. I don't think it was very important. I'll just emphasize maybe a couple of points of things that might be slightly complementary to what has been stated here. First of all, I compliment Hanen's keynote earlier. I agree with virtually everything in the presentation and think he lays out the priorities very well and also makes the case for why open source plays an important role here. Everyone has been emphasizing data and exposure of information. I think for Qualcomm, and I think a lot of representing a lot of views that have been expressed in ORAN, for example, exposure of data and having a framework for getting data out from all layers, as well as providing APIs for intent-based control to evolve to the kind of APIs that are going to be necessary to build AI and machine learning-based orchestration and operational software on top. So we have kind of the overall overarching vision of organizations like OAI Alliance, which focuses a lot on the broader AI orchestration, as well as enabling native AI throughout the stack and uniform access to platforms and hardware that implement all kinds of acceleration hardware, including GPUs, NPUs, DPUs, and PUs that we can't even imagine that will be here by 2030 when 6G starts becoming real. I think the vision for OAI and OAI in Duranta perspective should be well beyond what has just been sort of the stack. We have stacks now. We have a 5G stack at a high level of maturity in open source form, and that's helping to build and support research projects for 6G while it's being standardized and developed for the first time. We actually have the open source ahead of when the standard is out there. 6G, I believe, 6G prototype systems will be there as early as commercial systems, most likely. So, but I think transforming it into sort of an open RAN and AI RAN kind of platform that focuses on exposure of APIs and information, the kind of things that are very difficult to get out of commercial systems by their nature and because of business models and everything like that, the open source is going to have to provide, and that will help us to be able to build those platforms into starting from the standards and then into commercializing them. The other point I wanted to make, which I'll throw out relative to Viavi, is there's intense interest in open source platforms for testing. and also in using AI automation for testing. I think those are really important research topics that present a lot of good opportunities and may help provide some of the financial foundation we're going to need to build this broader open source vision of where OAI and Duranta evolve.
Okay, thanks, Doug. All right, let's move to Hannes. So we already here heard Hannes' keynote. I really enjoyed listening to that. Let me ask you the question now that I wanted to, that I held back before. So when listening to your keynote, I got the impression that when we're looking at 6G, the focus is no longer on the actual features of the network that focus the consumer, so what the consumer sees. But in 6G, the focus is more on how we deploy these networks, how we make it even more efficient and more easy to deploy these networks. Would you agree with that statement? Is that what we should focus on in 6G?
That's a good question. So the specifications and the work that's going to be done is most probably and has been always on the service, right? Yes. How the service is built and how the network elements interact between them. I will not expect that will change. There is going to be a lot of introduction of AI into everything that is being done so far. But one of the critical aspects of bringing all of that into reality, as you mentioned, as what the purpose is of the panel, right, is being that while 5G was being specified, there was a transformation happening in the network, the cloudification of the network. Unfortunately, that didn't match in terms of timing. So we end up with a specification that doesn't account for where those specifications or the functions that will be delivered we're going to be living on. So, and this is one of the things that I want to highlight. Let's try to repeat that mistake. Take into account that there will be infrastructure where all these functions have to live for 6G. And I think it's clear now that that infrastructure will be a cloud-native infrastructure. Well, cloud-native and AI-native infrastructure. So that was where I wanted to go in terms of looking in the future releases of 6G when 6G is going to be actually implemented. Now you mentioned about, and I think agree everything that has been said so far in the panel about the importance of open source, and I think everybody understands that is critical for the telco industry, and that is not just a word. I think for most of you that are here with us here in Austin and in the US, if you are using cellular network right now, there is a big chance that that communication or that access to the internet you have through those networks are being implemented on open source platforms, as we have been working with many of the customers here in the US. So the cloudification happened already, is on open source platforms. This is one of the things that we do at Red Hat. The open source have a pace that is much faster than anything else out there. And what we do at Red Hat is we bring that innovation from open source into an enterprise-grade or telco-grade capabilities that are implemented right now in the networks as we speak. Now, what we are going next is bringing that same way that we bring the capabilities to virtualize all the infrastructure for the network functions. We are bringing now as well the same capabilities for introducing AI in the different aspect of the operation of the network. So that will be as well a reality well, I will expect by the end of the year, but we're probably going to have better news at Mobile World Congress next year.
Okay. Well, looking forward to that. Thank you. Ganesh, yes. I think you did prepare some slides. Let me pull them up. Let's hear your views on how we can bring ideas to reality in 6G times. Yes, they're here. There you go. Are you on the clicker?
I just have one slide. Yeah, so I just wanted to talk with reference to this slide. Basically, it's a simplified view of the open innovation ecosystem, as I call it. And of course, I didn't want to put too much detail here. The underlying standards which are enabling the open reference designs and the open source community in general with respect to RAN. I think there was a good slide from Hanan earlier this morning. We have multiple organizations, right from 3GPP, OAI Alliance, Small Cell Forum, TIP, CNCF, and Hanan's slide captured that anyway. So with that enabling this thing, and we are seeing this, Radisys is a software vendor. We are a CUDU software vendor, and we've been supplying software technology for RAN for more than 3 decades now. So that gives us a good perspective of how commercial players and open source projects have evolved over a period of time, right from the 3G days or even 2G days to where we are in 5G and looking into 6G. So we see this happening in 3 vectors in terms of the infrastructure. One is cloud, of course. A lot of RAN functionality is going to be cloud hosted. It's already getting cloud hosted in 5G. More so in 6G. And the journey really started in 4G with the EPC, the packet core, and has evolved very fast for the RAN side as well, both in public cloud and private cloud. We're seeing this combination of cloud and edge allowing us to do the distributed placement of workloads as per the use case and the demands of latency, bandwidth, and everything, right? And the other vector is hardware, and the RAN compute, which needs some specialized hardware in some specific processing in algorithms and some of the coding, decoding. So we have traditionally used, one thing that the Open RAN movement achieved is moving away from the custom hardware or custom silicon as much as possible. And we are in an era of a lot more COTS hardware, merchant silicon, that is available for every player who's willing to create a product. So we see that as a combination of AI-specific hardware or compute and the RAN compute as well, whatever special needs of acceleration we have, whether it's inline acceleration, Lucas side acceleration, which is being used in 5G, and whatever shape it takes for 6G. So those will be another vector. And the AI models can also be seen as the AI infrastructure needed for running the whole network, not just the RAN, even the core network. So the intelligence that is going to be enabled through these AI models, especially for RAN, all of these 3 combined is going to enable a lot of open reference designs. And the standards community will do its work, especially OAI Alliance. If you see, we have reference designs already developed for different use cases, hardware reference design and software reference design in OAI Alliance. And now open source projects with the support of a community or an umbrella organization like Linux Foundation can make this possible, or is already making it possible in 5G now, with different kind of use cases and multiple open source projects. Maybe we will combine forces. We see the possibility of doing a variety of RApps, XApps, and DApps, and the more advanced topics of challenging topics, maybe ISAC and other things, integrated sensing and communication, which are part of 6G. Now, we have the ability to do these implementations on a forward-looking basis to enable faster implementation, both open source and commercial implementations. And we are also talking about a lot of AI functionality being embedded, infused in all aspects of the RAN, including CUDU and even the RU functions and the file layer functions. What it takes, what kind of research it takes, what kind of new models we need, algorithms we need, approaches we need in software and AI both. We are going to see that evolve over a period of time as we evolve into 6G. And this is going to be possible only with the active involvement of both industry and academia. And that's going to be made, I would say, enabled by this larger community of open source ecosystem. And if we do this right, we get a open and intelligent network, which is a futuristic RAN. And also to address the other question which was being discussed in the panels earlier, we create a futuristic workforce also, which is very skilled in RAN and the broader wireless technology.
Okay, thank you, Ganesh. Let me take this back. So thanks for that first round. Let me at this point check if there's if there are any questions in the audience for our panelists. We have time. Oh, there's some back there. Camille, would you?
So with AI being integrated into DApps, RU, the RAN itself, how much of a concern is poisoning or even prompt injection attacks? And if it is a concern, do you have any specific testing or validation or mitigation strategies that you have in mind?
All right, who wants to take this question? Chris, maybe? Or,
Sorry, Miss, what was the concern?
Can you repeat the question again?
Yeah, so with the integration of AI into all parts of the system, how much of a concern is poisoning or prompt injection attacks? And if it is a concern, do you have any strategies for how to mitigate it or how to test for it?
Well, I think the first question, or the question I would like to clarify is how would you inject those prompts in the network?
More poisoning than prompt injection.
You mentioned DApps, and I think you had in mind where perhaps external input or applications or code could potentially find their way into the RAN or running on the RAN platform. And so I don't know that I have an answer for that, not being a DApp expert, but...
I can make one comment, right? So certainly the problem is recognized, right? It's not something that NVIDIA is not aware of. In more mature parts of the company, right, where there has been the centerpiece of NVIDIA business, these sorts of considerations of data poisoning and trying to deliberately confuse neural network training and inference is being worked on. I must say, for the wireless part, it's a road for us yet to be traveled, right? It's something that we're aware of. To be frank, we're kind of busy just getting the fundamental infrastructure for many of these things in place, and the important concepts that you bring up, at least at NVIDIA, we haven't got to yet, but it is deemed as a important problem, and we get asked about it too from our commercial customers. So I don't think I've got a concrete answer for you, but a little bit of color from the NVIDIA perspective.
Okay, Doug, you wanted to something there?
Yeah, I would say in general, certainly from Qualcomm's perspective, from our research folks, we view these things like XApps and DApps as being largely research and experimentation platforms and tools. We're not big believers that commercial RANs at scale, at least maybe private networks will be built out of open source and allow open programmability at a higher degree. But in major commercial systems, the access to coding and programming any of those at that level will probably be very restricted. Now, I think there are really interesting advanced topics to consider whether you can poison AI algorithms by simply sending a certain data pattern, through the radio signal, or even a poisoned IQ samples in a knowledgeable manner. When we look at the degree of advanced attacks on, say, Intel and ARM CPUs to violate internal firewalls between virtualization boundaries, for example, that they're doing things like row hammer attacks of repeated operations. So one can imagine that an IQ sample row hammer might exist in the future, and it might very cleverly be able to exploit an AI engine, especially if you have knowledge of what's in the radio or what's in the DU, or certainly at higher levels. And so the industry will have to be extremely vigilant about trying to detect and avoid those kind of problems. But you know, it's a cat and mouse game between security, white hats and black hats, right? Always.
Yeah, I would like to add to what Doug said, right? So this level of variability, or I would say the system behaving in a non-deterministic fashion, we are going to avoid that by various levels of product development measures, including the security testing, and all malicious inputs. And you said probably any malicious pattern or input that can adversely affect the functioning of any function of RAN. We're going to avoid that, and then basically in addition to the training and inference, we're going to do that level of testing just to be sure that this is behaving deterministically, and any malicious input is identified and addressed accordingly. So are we doing that already in the products? Not yet, because this is still in the exploration stage, but this will be done before it's rolled out in the network.
All right, Ben?
Yeah, maybe just to, I think, you know, undercutting the need for trustworthy AI in these systems, right? I think, like, I agree with the other panelists. Like, it does feel somewhat early. We're still trying to figure out what's the best way to apply RAN or AI at every level of the RAN, and figure out where, you know, what's the correct advantage or disadvantage there. But I think it goes back to really looking at both data and then test approach to really be able to say, like, I think, you know, in the smart scenario work that we were doing, like, a lot of what we need to understand is if some of these AI models are not intended to have long training periods and are really supposed to be just live inference models that are just taking their best guess, what we want to be able to ensure is that there is an appropriate test framework for identifying where, you know, the hallucinations, let's say, will become. Because I don't think we have an understanding of how these edge AI functions will hallucinate like our LLMs do now. Right? We've got to get there. We've got to plug away at that. But I think that's really where we have to have a good understanding holistically of what's happening to the system, because we will find that there will be ways to provoke or change an AI based on maybe, you know, tackling something somewhere way else in the network that then has downstream implications. So I think it really comes back to, and this is where the openness of these reference architectures is important, because we have to understand what's happening inside them, because unfortunately with some of these AI tools, we don't know what's happening inside of them.
Yeah, exactly. That's a very good statement. I agree that we're still in the beginning of developing and understanding all of these AI tools, the benefits for the RAN and benefits for the networks, and then we have to you know, figure out the security questions as well. There were two questions back there, and then Kaushik.
There's a distinction between AI for RAN, right? So those are things that AI and applications that make the networks more efficient, power efficient, of the resources and spectrum and all of that. And then there's AI on RAN, which are those applications that are on top of the network that that sort of can address things like collective intelligence, distributed intelligence, and ISAC could probably fall into that. Maybe there's some, you know, scheduling, like just looking at this diagram. But like how much effort is going into like the AI RAN that at an architectural level, like down to the PHY level, to enable the network to support both AI for RAN and AI on RAM? And like, is that just all embedded in you know, these DApps? You know, because I think we need to like peel that onion a little bit more.
Okay, who wants to take that? Chris, you want?
So it's a quick, and one of the questions is, how much effort is going into
either research or deployment of architectures that are really getting at. So I'm interested in sort of distributed intelligence.
I mean, from my perspective, I would claim a lot, right? Here's one data point, right? It's kind of one view of the world. But if you come in and look at this from the AI RAN Alliance, right? So I chair working group 1 there, which is AI for RAN. And there's over 100 companies in AI RAN Alliance, right? Major, tier 1 names in AI RAN Alliance. All of them have projects under the umbrella of AI for RAN. And we have, I think, 17 active work items, all of them related to either application of AI/ML in the physical layer or in layer 2. So I would think a lot. And I would also say not all of it is kind of appropriate for DApps, right? Some of it is kind of, just by the nature of the timing, necessary to put it right in the heart of a high-speed processing pipeline. So I don't know if that partially answers your question. And certainly a lot of activity on ISAC, right? I don't think you can move anywhere without hearing that acronym now, and whether it straddles AI for RAN or AI on RAN, right? I think it's both.
Okay. Kaushik, you want to take my mic here?
So my question to the panel is, the whole, the vision behind this disaggregated ecosystem is to allow innovation by the small players, right? So here's this great idea. You can go and innovate in a certain layer and then not worry about the rest. So let's say Kaushik and his students come up with an awesome XApp, okay? Walk me through the steps through which someday this XApp might eventually reside on an operator's network, okay? Who does the test and measurement? Who does the certification? How do I convince the next step and the next step and the next step? So help me realize the vision of an entrepreneurial spirit that this disaggregated system will encourage.
Oh, yeah, that's an excellent question.
Okay, I'll take this question. And from an ORAN Alliance point of view, I think right now the level of certification that exists is mainly for the components. When I say components, the CUDU, RU, and other elements. To an XApp level or an RAP level, I think maybe it's getting updated. And there is a focus group for this. There's a test and integration focus group, which does the badging and certification. So for specific use cases, we still will be able to go through this exercise through a platform called a RAN Intelligent Controller. And the eventual goal for any such developer or anyone trying to even start a new company and selling this should be to go through this lab exercise, then find a willing operator to deploy and try this in their network, let's say, and then go ahead and deploy this on a wider scale, right? And there are examples of companies doing this in specific areas, and it may not be appropriate to quote their names here without their permission as well, but there are examples of those already happening, because they focus on very, very specific problems. And the whole idea of opening up this ecosystem is to bring that approach of best of breed. Whatever each of these small or big companies, they may not be a traditional RAN player, but they have a play, because everything almost is becoming softwareized. Right? And there is an opportunity for everyone to bring in improvements either in the end-to-end performance of the network or for the end user, some benefit for the end user, right? So you have the opportunity. And is that a very mature, robust system? At least I'm not sure whether at an XApp or app level, DApp level, we have the full framework in place.
Yeah, I might comment on, I think you rightly addressed the easiest part of the question, which was testing and certifying the app and the framework. Maybe a little bit controversially again, we don't believe in that it's going to be commercially very realistic to open up for externally written commercial XApps and DApps and things like that. They'll have to be done in tight cooperation with the RAN vendor, most likely at that level. So I think a lot of the focus is going to be on this sort of so-called magical intent-based control, which will be much more sophisticated from the non-real-time RIC and the SMO, the system orchestration layer above, but at the same time, we hope to have much more deep exposure of internal data and analytics all the way down to relatively low-level raw data from the lower layers, the physical layer and the MAC layer and so forth, to inform training and algorithms above. So, you know, it may evolve in a direction of a more open ecosystem eventually, where you can program at a lower level. But I think it's going to be difficult. That said, those are excellent tools for doing research on algorithms, right? If you want to research RAN lower layer, you know, physical layer techniques for doing Isaac algorithms, that's a really good framework. And I applaud NVIDIA for making a platform with that exposure available, and having the compute power, including GPUs and lots of conventional processors as well, to support that kind of research. And that's why open source at those layers is so important to support that research. Mapping it into commercial will be a little more challenging.
All right, we're almost out of time here. Chris, you had another comment?
Your XApp into a Tier 1 network equipment provider's equipment. So maybe applying pressure to the mobile network operator, if there's really value there, they're the ones that have the big hammer to be able to influence the network equipment provider. But the other part is, I think, right, at the moment, if you look at what's going on in Department of War, right, around many proof of concepts, they're very open to, you know, in their proof of concept systems, being able to understand what can you do with XApps, RApps, and DApps, and maybe even Akudu, right, has a role to play in that as well, right? Maybe that's a little more pliable area to be able to take an idea from academia or even industry and get it into at least, you know, proof of concept systems in these private 5G networks.
You want to?
Yeah, I think, you know, I think, too, it's good for us to look and recognize how far things have come in the past, like, 10 years. I remember the Valley of Death conversations we were having around 2016, 2017, about how it was impossible to get anything out from academia into industry to influence this. And then you see, as we've made progress there, I think Open RAN has helped bridge that gap a good bit. But, you know, I think this time last year, we were here at UT, and all of the commercial folks were saying, hey, we only care about optimizing a use case that's going to make us, you know, profitable. This is what we care about. And the academics in the room were like, well, what do we do then? Like, this is we're academics, we research. And so I think part of it is being able to scale, right? We do have to start being able to prove that what can happen in research actually can make an impact on the overall network. And so being able to take something from your lab and being able to scale it out to something like, I know we've got ERA and AirPaw and the power platforms, like being able to get it to something where you can actually start justifying the impact that it's going to have. Because at the end of the day, I think it's really, the bar is very high right now, and the good news is it's lower than I think it's been, but it's still a high bar, and so you have to really be able to do these demonstrators at scale to be able to convey value to the MNOs.
All right, Hanan, you want to do the last statement?
Okay, go ahead.
Okay. Hi, everyone. This is Federico from Red Hat. I'm a solution architect. So you're asking for a practical path to get the idea from academia, such as XApps, DApps, something that gets created, to commercial. Okay, I'm going to be very controversial, but probably Hannah is going to cover that one as well. Well, if I have to put myself, you know, in the shoes of the students, you will need a relationship first with vendors. You need to make those connections. And one way to do that is, of course, through open source, which is very important. And one way you approach the vendors is that you do proof of concept together with them. so that they can, test and like present whatever X app, D apps, or whatever product you created. When you do press release together, such as like, oh, Red Hat does work with, this to do that, and you start getting visibility, because you need visibility. The suggestion that Ganesh made about Oran, the problem of Oran is that if you want to do the plug fest, you have to pay. Right? You want to do the certification, you have to be part of it. There is an investment that you have to make. Is it worth it? Yes, if you can do it. If you cannot, you got to find different ways. So in my opinion, you need to build those relationships. You need to get your product out there, get visibility. Of course, the product has to address a real need for the operators that are going to be the end customers. So you need to work with the entire ecosystem. That's my personal opinion.
I second that. I think open source collaboration and on organizations is going to be a path forward. I'm going to do it really fast. Okay. So one of the challenge, especially for the X app and our apps and the apps, is actually most of them. Even now, when we are introducing AI into all of that, is they're going to need data. And unfortunately, most of the data coming from the network are stuck in the network. There is no access to that. So unless you are prototyping directly with a real network, you will not be able to train your models in such a way that it will work at scale. So for all of that, is up to everybody to try to put as much data as possible as well out there. So I mentioned this morning about one of our initiatives where we are actually experimenting with real data from networks into how to be able to build models. And there is a lot of open source available out there to help you out through that journey.
All right, thank you very much. I really loved that last round of questions. Thank you to the audience for asking the questions. Thank you to all the panelists. Let's give them a round of applause.